Okay, so this is a recent Cider 2021 paper. It's about new directions in cloud programming. This reads more like uh, funding proposal written to National Science Foundation, where you have to show and convince people of an ambitious vision and show that you have some early steps to realize this vision. So, and the problem is very interesting, obviously. It's about cloud programmability. I think this is not a contentious statement. It's hard for most developers to harness the enormous potential of the cloud. Cloud gives you capability to elastically scale to high and low, but how do you take care of, how do you achieve all that potential? How do you write distributed programs for the cloud? Even the experienced developers would run into problems. And the paper argues that cloud does not provide a programming environment that exposes the inherent power of the platform. And then it proposes this agenda for providing new generation of cloud programming environment to programmers in an evolutionary fashion. The evolutionary fashion will be an important point which we will discuss later in the presentation. But let's think about the cloud programmability model. Did the cloud not provide any programmability model? Well, you can argue it did. I mean, even starting from as early as 2005 with MapReduce, later with the extension of that to Spark with in-memory and not just map and reduce operations with many operations, like a data flow like approach is a good abstraction for cloud programming, I think. It gives scalability not just for one machine, but scalability across machines, and environment would be the Spark environment, for example, or TensorFlow, similar story you can write, and then the components of the data flow diagram in the TensorFlow could be scaled later. So I think there are examples of that already. But the problem, I think, is about, how easy are they to use? Is it possible to provide something general, or are they high level? I think the paper's position is that even this serverless or function as a service, even if we have it, even if the cloud gets it right, and they had another paper about what it means to get it right, to provide more distributed facilities, network addressed of functions, etc. Even if it is possible to get, even if the cloud providers get the serverless right, it argues this is a low-level assembly language for the cloud. This is their analogy for it. And this is still a simple infrastructure for launching sequential code without programming model to host it, meaning that with no guarantees about the distributed execution of it, right? And then the argument is that we should give a next generation technology that allows developers to address the distributed concerns gradually. The evolutionary approach, again, is mentioned here, working with the assistance of new automation technologies with a lift and support compiler that we will discuss. Here, another discussion point is about the distributed concerns. Toward the end of the presentation, I will raise this issue again, but maybe the developers don't need that much distribution, right? I mean, the cloud providers provide a simple model to use like Lambda. Yeah, it has a lot of shortcomings. It doesn't talk too much about the distributed programming model, what happens with concurrent execution, but maybe the needs of developers are not that distributed. They have more mundane, embarrassing or parallel, let's say, workload. So this is another thing to keep in mind. Yeah, of course, this is a research agenda for cloud programmability, so it's ambitious, but maybe that the state of the art of the cloud is not that bad, because there isn't much need for distributed, and most of the workload, most of the applications is embarrassing the parallel, which is taken care of by the existing cloud services. Okay, let's move to their agenda. They envision the programming framework to consist of independent facets, and they name 4: program semantics, availability, consistency, and targets for optimization. The vision is that the developers would be able to provide at high level some declarative specifications of these, and lift and support compiler in the program semantics would be able to lift this to language, intermediate language that the compiler understands, and the compiler and the framework tools treat these facets independently of each other and help with the cloud deployment. They are arguing availability is an orthogonal issue of consistency, which is an orthogonal issue of scalability for the deployment. Okay, so let's start with the program semantics. So one of the authors had work on lift and support architectures. The idea is that for a narrow domain, it's possible to write a DSL, domain-specific language. And then in this DSL, you can write sequential-like programs. And these could be lifted and to higher level, maybe declarative, maybe calm program, intermediate representation that the compiler uses. And then from there, you can add the other facets, availability, consistency, and this different targets for scalability. And for the ones that you cannot automatically lift, maybe you just relegate them to serverless functions. Okay? So here is the picture they have in mind. You have some DSLs. The DSL idea would only work for limited context, narrow constraint applications. If you try to target a very general application, or if you try to keep this very general, it's not possible to do this lifting and the things after that. Okay, so they call this the hydro stack. Maybe the entire thing is a pun on the hydraulic, because you use a lifting first from DSL to the hydrologic, the intermediate representation that the compiler supports, more like a declarative program at the hydrologic level. And hydraulic is the lifter, verified lifting, to do it, to lift a given program in a DSL to hydrologic. Then the argument is that with the compiler support, it's possible to address different facets of the deployment separately. The compiler then produces hydroflow program. They mentioned somewhere that this could be an efficient language like Rust and lower level. And then this would be deployed through hydroflow deployment. And the other thing they mentioned that this hydrologic thing would be intermediate representation would be human readable. And so the evolutionary approach is that developer would be able to look and tweak them. It will also give the developer some way to hand tune or change it, modify it based on context. Okay. The availability facet. What's the availability facet? Availability facet is like fault tolerance. How many replica failure you like to tolerate? And they are saying that it's possible to build this thing into the program as a separate facet. There is an example we will cover later. And then the compiler would help in synthesizing the code to provide this availability guarantee efficiently. So it's an ambitious vision. Consistency, similarly, it says that consistency should be treated as a different facet. There is another author that has done work on consistency, especially the visible consistency versus behind the curtain consistency. So even when you require strong consistency to the client, that doesn't mean that you have to serialize everything in the implementation, because there is a curtain between the client and implementation. If you try to serialize everything, that's not an efficient program, and that doesn't work well for distributed deployment. But the idea is that in this seminar, we have seen several examples of it. It's possible to hide some of them and only expose an update when it is safe to expose it for linearizability. For example, the timestamp-based approaches, they say that, yeah, use timestamps. And then when the timestamp moved to this, what was it called? The lower watermark that it's replicated to everywhere, then you expose this operation as completed. So it's possible to pull tricks like that to exploit client-level consistency visibility and do some things behind the curtain for relaxing the consistency requirements and allowing more concurrency for distributed programming. And of course, Joe Hellerstein had previously done work on monotonic programming, etc. That is relevant here. Okay, finally, targets for dynamic optimization is about auto-scaling of it, of the application deployment from a single node to multiple nodes and even across regions, and maybe later back to a single node again, based on the workload and the demand. And they are arguing that this could be also a separate thing that the compiler can help for deploying, and the developer would only give high-level directives like trade-offs between cost, latency, and availability. So as promised, the evolutionary approach to revisit that, they are saying that this should allow the developers to look at the generated IR code and refine it for their use later on. Programmers would be able to improve the generated programs incrementally by modifying the lower level facets and or hinting the compiler some constraints. So going back to here again, so DSL, this verified lifting gets it to hydrologic, and it would be possible for the developer to change things maybe at hydrologic level or hydroflow level to give improve things. Okay. So it gives an example, pseudocode example of a sequential DSL program that this would take. For example, one of them sequential code and it also gives a pseudocode of the hydrologic that's generated from this. So this pseudocode will have a data structure called table and some functions, okay, like a sequential program. The trick is that the lifter Hydrolog is going to compile this into this IR intermediate representation called hydrologic. The hydrologic semantic is that there is an event loop, and this is like round-based, tick-based loop, and it at each iteration, the specification, the programmer specification, would be used to compute new results from the previous snapshot. So maybe like snapshot isolation semantics and atomically update state at the end of each tick. So the round abstraction, and within each tick, within each round, all computation is done to fixed point, so that the order of the computation within a tick would not be a problem, would be irrelevant. So that some kind of order independence within tick. So this is the generated pseudocode from the given DSL pseudocode. And you can see there are concepts like queries, and you can see some of the facets like availability. And one thing that they mention in the paper is line 33. You know, even though this looks like it should be atomic, for example, people PID vaccinated through, they say that since this is partitioned and per PID, the operations would not affect the other people vaccinated operations, it's possible to treat this as a monotonic mutation. So that's an example they give, and it's possible to narrow down the non-monotonic mutation to a couple lines, like maybe the line 34 in this hydrologic program. And as I mentioned, then this is compiled down to more efficient representation they are proposing. Maybe Rust would be suitable for that. So as for discussion, I brought this up. You know, they also mentioned in the intro that cloud services are making billions of dollars. It's hard to argue for that. And so maybe, yeah, people don't need that much distributed support for now, as the evolutionary process will take care of it, as there would be more need for more coordination requiring applications. Those frameworks would also be developed. But right now, for example, serverless is extremely successful. Why? Because most of the workloads, most of the applications is embarrassing the parallel applications where the serverless approaches would suffice. So maybe cloud services are giving what is most needed by the users, like 95%. The other 5%, maybe it's not servicing them well. Yeah, sure. And this is a research agenda for future looking. That's also right. But maybe for now, there isn't a very pressing need. It would be nice to have this, yes. How feasible will this be? We will have to see. It would not be very general. It would work for specific domains where you can have DSLs. If you try to make this too general, it would not be very easy to implement this. Another discussion point I want to open is, I mean, do users really care that much about performance? I mean, history told us that they didn't. Actually, I was also repulsed by this around starting from, maybe 2008, going to 2013, 14. Hadoop MapReduce was very, very popular. And this is a very wasteful platform, very wasteful way of doing things, and not in distributed system spirit, but it was easy to use. That's what people cared for. They didn't care that if they programmed this carefully, this would run in 30 minutes. But they would be okay to write MapReduce or even at higher level at PIG, etc., and let the machines churn, the Hadoop platform churn on this for 8 hours and get some results later on. So I think maybe when developing a framework like this, ease of development may be the dimension to prioritize over other dimensions first. Otherwise, it may not be as easy to use, and it won't get a lot of adoption. So yeah, so those are my points for discussion.